Hi everyone, and welcome to this video going over lesson 8.2, writing equations. In the last video, we talked about how parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. Remember that because it's going to be important for this video. But what I want to start with is reviewing slope-intercept form. You probably remember it as y equals mx plus b, where the m is our slope, and the b is the y-intercept, or the starting place. So given the following equations, I want us to identify the slope and the y-intercept. The slope is the m in front of the x, and the y-intercept is the constant being added at the end. So in A, we have y equals negative 2x plus 1. This means that the slope is negative 2 because it's in front of the x. And the y-intercept is 1 because that's in the B spot. For question B, I have y equals 2/3 x minus 4. So my slope is 2/3 because that's what's in front of the x. And the y-intercept is negative 4 because that's the constant. And then lastly, part C, I have y equals x plus 7 over 9. Since nothing's in front of the x, remember we can always put an imaginary 1 in front of x, and so my slope is 1, and the y-intercept is the 7 over 9. Now that we're able to identify the slope and the y-intercept from a y equals mx plus b equation, we are going to combine this with our knowledge about parallel and perpendicular line slopes. So based on what you know about slopes of parallel and perpendicular lines, determine what the slope would be in each scenario. Remember, parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So in A, it says, what is the slope of a line parallel to this line? Well, the slope of that line is negative 2, and parallel lines have the same slope. So a line parallel to this one would also have the slope negative 2. Parallel lines have the same slope, so the slopes should match. In B, it says, what is the slope of a line perpendicular to this one? So the slope of the line they gave us is negative 2, but in order to find the slope of a perpendicular line, I have to find the opposite reciprocal. Since this is a whole number, I'm going to put an imaginary 1 underneath. And to find the opposite reciprocal, we flip and change the sign. So this is going to be a positive 1 over 2 for the slope of the perpendicular line. Let's try this again. In C, slope of a line perpendicular to this one. So the slope of this line is 2/3. And if I want the perpendicular slope, I need to find the opposite reciprocal. So I need to flip it and change the sign. So flipping 2/3, I will get 3 over 2. And since it was positive, it is now going to be negative. And so negative 3 over 2 would be the slope of my perpendicular line. And then lastly in D, the slope of a line parallel to this one. Well, the slope of this line is 2/3. And parallel lines have the same slope, so the slope of the parallel line will also be 2/3. In part C, it says Carly wants to draw a line P so that it is parallel to line N and passes through the point negative 2, 3. So if I plot negative 2, 3, Carly wants a line that is parallel to the one drawn and goes through that point. Well, I know that parallel lines have the same slope. So let's find the slope of line N because that will also be the slope of line P. I'm going to pick 2 points on line N that cross at perfect corners, such as 0, 2 and 8, 3. And I'm going to count the rise over the run. So the rise is 1 unit, and the run is 1, 2, 3, 4, 5, 6, 7, 8 units. So this means that the slope of line N is 1 over 8, which means the slope of line P also needs to be 1 over 8 because parallel lines have the same slope. Then it says, what is the equation of line P written in point-slope form and in slope-intercept form? Well, slope-intercept form is our y equals mx plus b, but point-slope form you might have forgotten. So let me remind you of what point-slope form looks like. In order to write point-slope form, I need to know the slope, which is m, and a point on the line. That point is x1, y1. So for example, we know that the slope of line P is going to be 1 over 8. So that is going to be our m value. And we were told that line P needs to pass through the point -2, 3. So that is going to be our point. So this will be x1 and y1. And so let's plug this in. I have y minus y1, which is 3, is equal to m, the slope, which we said was 1 over 8, parenthesis x, minus x1, which is -2. This is point-slope form. And notice how I have 2 negatives in the parentheses. If I have 2 negatives right next to each other, this can turn to a big plus. This is point-slope form. Once you have point-slope form, we can find slope-intercept form by solving for y. What I'm going to do is I'm going to distribute. So I'm going to have y minus 3 equals 1 over 8x plus 1 over 8 times 2. Whenever you have a fraction multiplied by just a number, all you have to do is multiply the top number. So 1 times 2 is 2. This will be 2 over 8. And then in order to get y by itself, I just add 3 to both sides. In order to add fractions, they have to have a common denominator. Remember, our denominator for just a number is 1. So I'm going to multiply both of these by 8, so I get a common denominator. This turns into 24 over 8. And 2 plus 24 is 26 over 8. And this is my slope-intercept form of the line. So, if we're told to write the equation of a line parallel or perpendicular to a given line, we can figure out the slope, and if we're given a point that also needs to be on the line, start with point-slope form. Y minus y1 equals m times x minus x1. Then, after you plug in those values, if you distribute and solve for y, you will get your slope-intercept form. Let's try this one more time, but with a perpendicular line. Juan wants to draw a line Q so that it is perpendicular to line N and passes through the point -9, 7. So it needs to pass through this point right here and be perpendicular to line N. So something like this. So we know from last time that the slope of line N was 1 over 8. And perpendicular lines have opposite reciprocal slopes. So I need to find the opposite reciprocal of 1 over 8, which means I'm going to flip it to get 8 over 1, and I'm going to change the sign. Since it was positive, it is now going to be negative. So the slope of line Q needs to be -8 over 1, which we can also write as just -8, since -8 divided by 1 is just -8. Now let's write the equation. I'm going to rewrite our point-slope form down here. Our slope is -8. And remember, our perpendicular line needs to pass through the point -9, 7. That is our x1 and our y1. So I'm going to plug in these values. y minus 7, which is y1, equals our slope, which is -8, times x minus -9. And since I have two negatives right next to each other, that's going to turn to a big plus. That is my point slope form. Now to get slope-intercept form, I'm going to use my point slope form, and I'm going to distribute the -8. So I have y minus 7 equals -8x minus 72. And then to get y by itself, I just add 7. And I'm left with y equals -8x minus 65. And that is the same equation, but in slope-intercept form. And that is how we can use the relationships of the slopes of parallel and perpendicular lines to write equations of parallel and perpendicular lines. Please let me know if you have any questions, and I will see you in class.